All right, now we can list out every single factor of a number, and that kind of takes a while, especially because you're having to do some division to make sure that it goes in evenly and all that kind of business. So there is another way to factor, and that's called prime factorization. And this is very interesting. The prime factorization of a number is a factorization in which every factor is a prime number. Very, very cool. The reason this is so cool is because it leads us to the fundamental theorem of arithmetic. And that theorem says any number greater than 1 can be written as a unique product of prime numbers. Now, let's go through an example and we'll go back to that definition and we'll talk about what that means. So here we have our first number, number 8, and we want to do a prime factorization of it. So we're going to use what's called a factor tree. I'm going to think of two things that multiply together to get 8. Now I don't want 1 and 8 because then I've not done anything. I'm right back to really where I started with the number 8. So I want to think of two different things that multiply together to get 8. So how about 2 times 4? Well, the number 2 is a prime number. Since that's prime, I'm going to circle it. Now 4, I can break it down further. I can think of two things that multiply together to get 4, and that would be 2 times 2. Now, every time I reach a prime number, I circle it. So I could say that 2 times 2 times 2 is 8. Or another way of writing that would be 2 to the third power. Because remember, your exponent tells you how many times you're multiplying that base. So 8 can be written as 2 to the third power. Any number greater than 1, 8 is greater than 1, can be written as a unique product, can be written in only one way, as a product of prime numbers. These are prime numbers being multiplied together. And so this is the prime factorization of 8. Let's try another one. Here we have the number, if I can move it up a little bit. Oh, you can't see it. I'll write it in right there. Okay, here we have the number of 60. And I want to think of two things, or I'm doing my prime factorization here. Let's think of two things that multiply together to get 60. And you may think of something different than I do, and that's okay. We will end up with the same answer. I'm going to say 2 times 30 is 60. So 2 is prime, but 30 is not. I can think of two things that multiply together to get 30. So I'm going to say 3 times 10. Now again, if you thought of something different, it's okay. 3 is prime. 10 is not. I can think of two things that multiply together to get 10. And that would be 2 times 5. 2 is prime, and 5 is prime also. We can't break that down any further. So to write this out as a prime factorization, we've got two of those 2's, so 2 times 2. We've got a 3 and a 5, times 3 times 5. So writing it more compactly would be 2 cubed, because we've got two of those 2's, times 3 times 5. And this would be the unique prime factorization of that number. Now, what if we had started off with something different? What if you said, well, okay, I didn't see that 60 was 2 times 30. I saw that it was 3 20s. 3 20s make $60. Well, 3 is prime, but 20 is not. So if we think of two things that multiply together to get 20, maybe we think of 4 times 5. Well, here 5 is prime, but 4 can be broke down further. 2 times 2 is 4. Now 2's are both prime. So if we were to write out the prime factorization again, I've got two 2's, so that's 2 squared, times 3 times 5. It does not matter how you start out. As long as your two things multiply together to get your number, it doesn't matter where you start. You will always end at the same exact spot.